Assalamualaikum warahmatullahi wabarakatuh. We are from group 5 and today we will be presenting chapter 4.2 differentiating polynomials and chapter 4.3 differentiating trigonometric functions. A polynomial is an equation in the form of an x to the power of n plus an minus 1 x to the power of n minus 1 and so on, where an are the constant coefficients and x to the power of n and x to the power of n minus 1 are the power of variable x. A simple example of a polynomial is quadratic. For example, x squared plus 3x plus 1. As we can see in the slide, the general rule is if y equals to x to the power of n, then dy dx equals to n x to the power of n minus 1. If y equals to 1, then dy dx equals to 0, because we all know that anything to the power of 0 equals to 1. So, the n is 0. The same can be applied to any other constant, not just 1. If y equals to c for any other constant c, then dy dx equals to 0. Let's say we have y equals to x. Then it is the same with y equals to x to the power of 1. If we use the general form, we will get dy dx equals to 1 times x to the power of 1 minus 1, which is equals to 1. If we have y to the power of x squared and we want to differentiate it, we can use the general form. Then it will be dy dx equals to 2 times x to the power of 2 minus 1, and then it will equal to 2x. Example, if the question asks you to differentiate y equals to x to the power of 5, the solution will be dy dx equals to 5 times x to the power of 5 minus 1, so the answer will be 5x to the power of 4. We can also use this rule to differentiate when x is raised to a negative power. In the example, the question asks to differentiate y equals to x to the power of negative 1. If we apply it to the general rule, the solution will be dy dx equals to negative 1 times x to the power of negative 1 minus 1, so the answer will be x to the power of negative 2.
The next one is differentiating trigonometric function. We have two rules, that is, if y equal to sin x, we differentiate, it will become dy over dx equal to cos x. And if y equal to cos x, we differentiate, it will become dy over dx equal to negative sin x. And the other one, when we have constant multiplying the trigonometric function and coefficient multiplying the x, it will become y equal to a, the constant, sinus b, the coefficient, times x. Then the differentiate equation will become dy over dx equal to a times b times cos bx. And if y equal to a cos bx, then the differentiate equation will become dy over dx equal to negative a times b times sinus bx. And next for the example, first, y equal to sinus 9x. We use the rule y equal to a sinus bx, then dy dx will become a times b times cos bx. So the a value is 1 and b value is 9. So dy dx equal to 1 times 9 times cos 9x. So dy dx equal to 9 cos 9x. Number 2, y equal to 4 cos x over 2. So we use the rule y equal to a cos bx, then dy dx equal to negative a times b times sinus bx. The a value is 4 and b value is 1 over 2. So dy dx equal to negative 4 times 1 over 2 times sinus x over 2. So it become dy dx equals to negative 2 sine x over 2. Number 3, y equal to negative 2 cos negative 7x. We use the same formula as number 2. So the a value is negative 2 and b value is negative 7. So dy dx equal to negative times negative 2 times negative 7 sines negative 7x. So the dy dx will become negative 14 sine negative 7x.
Assalamualaikum. My name is Fadil Hasha binti Syaful Bahri. Now let's move to the next example of trigonometry differentiations. In X-ray crystallography, the Bragg equation relates the distance d between successive layers in a crystal, the wavelength of X-rays lambda, an integer n, and the angle through which the X-rays are scattered theta in the equation lambda equal to 2d over n sine theta. What is the rate of change of lambda with theta? So the rate of change of lambda with theta is d lambda over d theta, which is the derivative of lambda. So we use this formula. If y equal to a sine bx, then the dy dx is equal to a b cos bx. So here we have 2d over n is a, and here we have v equal to 1. So the d lambda over d theta is 2d over n. The derivative of sines is cos. So cos theta as x. So cos theta. So the answer is here.